Hello everyone, this is Kalpana here. In this video we are going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to x into f1 of x plus t plus f2 of x plus t by eliminating the arbitrary functions f1 and f2. Here we are given a relation and we are asked to form a partial differential equation from it by eliminating the arbitrary functions f1 and f2. So let's see. Given z equal to x into f1 of x plus t plus f2 of x plus t, right? Consider it as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating one with respect to x. Here we are having two independent variables, x and t are independent variables, okay? Fine. Now just apply dou by dou x on both sides of the equation. You'll get dou by dou x of z equal to dou by dou x of x into f1 of x plus t plus f2 of x plus t. This gives us dou z by dou x equal to, here we have two functions, right? Since we are partially differentiating with respect to x, so we'll treat t as constant, and here we are having two functions. So we are going to apply uv whole dash formula, which is u dash v plus v dash u, right? So you'll get partial derivative of first term, that is dou by dou x of x into f1 of x plus t plus partial derivative of f1 of x plus t into this x, okay, plus partial derivative of second term. This gives us dou z by dou x equal to partial derivative of x with respect to x is 1. We'll get 1 into f1 of x plus t plus partial derivative of f1 of x plus t is f1 dash of x plus t into inner derivative dou by dou x of x plus t into this x, okay, plus partial derivative of f2 of x plus t is f2 dash of x plus t into inner derivative dou by dou x of x plus t. This gives us dou z by dou x equal to f1 of x plus t plus x into f1 dash of x plus t into partial derivative of x with respect to x is 1 plus partial derivative of t with respect to x is 0. Since we are partially differentiating with respect to x, so we'll treat t as constant here, okay, plus f2 dash of x plus t into partial derivative of x with respect to x is 1 plus partial derivative of t with respect to x is 0. Well, this becomes dou z by dou x equal to f1 of x plus t plus x. 1 plus 0 is 1. 1 into x is x. You'll get x into f1 prime. 1 plus 0 is 1. 1 into f2 dash is f2 dash. Right? Now, consider as equation number, say, 2. Now partially differentiate 1 with respect to y. Partially differentiating, actually you can differentiate equation 2 with respect to x, okay, or you can find partial derivative of y now. Differentiating partially with respect to y. Okay, as usual I'm just finding partial derivative with respect to t, not by t. Partially differentiating 1 with respect to t. Okay, usually we used to do we'll find partial derivative of 1 with respect to y, but here since we are having a second variable, independent variable as t, so we are doing it for t. Okay, in textbooks, you can see that they will be finding a partial derivative of this with respect to x again. We will also do that, but later. But now let's apply dou by dou t on both sides of 1. This gives us dou z by dou t equal to, here we are partially differentiating with respect to t, so we'll treat x as constant. Okay, we have constant into partial derivative of f1 of x plus t is f1 dash of x plus t into inner derivative dou by dou t of x plus t plus partial derivative of f2 is f2 dash of x plus t into inner derivative dou by dou t of x plus t. Right, this gives us dou z by dou t equal to x into f1 dash of x plus t into partial derivative of x with respect to t is 0 plus partial derivative of t with respect to t is 1 plus f2 dash of x plus t into partial derivative of x with respect to t is 0 plus partial derivative of t with respect to t is 1. This gives us dou z by dou t equal to 0 plus 1, 1 into x into f1 dash is x f1 dash. 0 plus 1 is 1, 1 into f2 dash is f2 dash. Consider as equation number 3. Now we got equation number 3 also. Dou z by dou t equal to x f1 prime plus f2 prime. Now let's find second derivative. We'll just apply dou by dou x on both sides of 2, or we'll partially differentiate 2 with respect to x here. Partially differentiating with respect to x. Just apply dou by dou x on both sides of 2. Here we are partially differentiating with respect to x, so we'll treat t as constant. This gives us dou square z by dou x square equal to partial derivative of f1 is f1 prime of x plus t into inner derivative dou by dou x of x plus t plus, here you're having two terms, right? So we are going to apply uv whole prime formula. So you will get partial derivative of x with respect to x into f1 prime of x plus t plus f1 prime, you'll have x into partial derivative of f1 prime, that is dou by, let's do it directly, x into partial derivative of f1 prime, let it be, okay, plus partial derivative of f2 dash is f2 double dash of x plus t into inner derivative dou by dou x of x plus t, right? This gives us dou square z by dou x square equal to f1 prime of partial derivative of x with respect to x is 1 plus partial derivative of t with respect to x is 0 plus partial derivative of x with respect to x is 1 into f1 prime plus x times partial derivative of f1 dash with respect to x is f1 double dash into inner derivative dou by dou x of x plus t. Okay, plus f2 double dash of x plus t into partial derivative of x with respect to x is 1 plus partial derivative of t with respect to x is 0. Fine. Now this gives us dou square z by dou x square equal to 1 plus 0 1, 1 into f1 prime is f1 prime, 1 into f1 prime is f1 prime plus x times f1 double dash of x plus t into partial derivative of x with respect to x is 1 plus partial derivative of t with respect to x is 0 plus 1 plus 0 is 1, 1 into f2 double dash is f2 double dash, right? And this gives us dou square z by dou x square equal to f1 prime plus f1 prime is 2 f1 prime. f1 prime is nothing but f1 prime of x plus t, okay, plus 1 plus 0 1, 1 into x, x into f1 double prime is x f1 double prime plus f2 double prime of x plus t, right? So this is our equation number 4. Now let's partially differentiate 3 with respect to t. Partially differentiating 3 with respect to t. Just apply dou by dou t on both sides of this equation. This gives us dou square z by dou t square equal to x is constant, right? X into partial derivative of f1 dash is f1 double dash of x plus t into inner derivative dou by dou t of x plus t plus partial derivative of f2 dash is f2 double dash of x plus t into inner derivative dou by dou t of x plus t. This gives us dou square z by dou t square equal to x into f1 double dash of x plus t into partial derivative of x with respect to t is 0 plus partial derivative of t with respect to t is 1 plus f2 double dash of x plus t into partial derivative of x with respect to t is 0 plus partial derivative of t with respect to t is 1. This gives us dou square z by dou t square equal to 0 plus 1, 1, 1 into x, x, you'll get x f double prime. f1, right? The 0 plus 1 is 1, 1 into f2 double prime is f2 double prime. Now consider this as equation number 4. Now we got dou square z by dou t square equal to x into f1 double prime plus f2 double prime. Okay. Now observe all these equations. Here you have f1 prime, f1 double prime, f2 double prime. Here you have x into f1 double prime, here f2 double prime, right? And here you have f1 prime, f2 prime, f1 prime, f2 prime. So we need to find dou square z by dou x dou t also. Okay, it's not necessary. I mean, it's not sufficient. I mean, these equations are not sufficient to find a partial differential equation. So what we'll do is we'll find dou square z by dou x dou t. Okay, why I'm saying is, see, just observe here you're having x f1 double prime and f2 double prime, right? This part can be replaced by dou square z by dou t square, but f1 prime remains, right? You just need some value for f1 prime also. Okay, if you want, you can find from this, but here you're having f1 and f2 prime, and here you're having f1 prime and f2 prime. So it's a bit difficult, okay, to find a partial differential equation. Not bit difficult, it's not possible. So we are going to find dou square z by dou x dou y by partially differentiating the term involving dou z by dou y with respect to x. Yeah, you have t right here. By partially differentiating the equation involving dou z by dou t with respect to x gives dou square z by dou x square, sorry, dou square z by dou x dou t, or we can write dou by dou t of dou z by dou x, right? You can write this as, right? So by partially differentiating the term involving dou z by dou x with respect to t gives dou square z by dou x dou t. Okay, so let's go for this. Okay, now I'll partially differentiate equation 3 with respect to x. Okay, partially differentiating 3 with respect to x. Let's apply dou by dou x on both sides of the equation. Right, this gives us dou square z by dou x dou t equal to, here you're having two functions, right? So you may need to apply this formula, dou by dou x of x into f1 dash of x plus t plus x into dou by dou x of f1 dash of x plus t plus dou by dou x of f2 dash, right? This gives us dou square z by dou x dou t equal to partial derivative of x with respect to x is 1 into f1 prime plus x into partial derivative of f1 prime with respect to x is f1 double prime into inner derivative dou by dou x of x plus t plus partial derivative of f2 prime is f2 double prime of x plus t into inner derivative dou by dou x of x plus t. This gives us dou square z by dou x dou t equal to 1 into f1 prime is f1 prime plus x into f1 double dash of x plus t into partial derivative of x with respect to x is 1, partial derivative of t with respect to x is 0 plus f2 double prime of x plus t into partial derivative of x with respect to x is 0, sorry it's 1, right? 1 plus partial derivative of t with respect to x is 0, right? This gives us dou square z by dou x square, dou square z by dou x dou t equal to f1 prime of x plus t plus 1 plus 0 is 1, 1 into x f double prime is x f double prime plus 1 plus 0 is 1, 1 into f2 double prime is f2 double prime, right? So we got equation number 6, dou square z by dou x dou t equal to f1 prime of x plus t plus x into f1 prime of x plus t plus f2 double prime of x plus t, it's double prime, which is equation number 6. Now using all the equations we have, we'll find the partial differential equation, the required partial differential equation. Let's see that. See, we have dou square z by dou t square equal to f x f1 double prime plus f2 double prime, right? Let's replace it by this one, then we'll get, we have 4 dou square z by dou x square equal to 2 f1 prime of x plus t plus x into f1 double prime of x plus t plus f2 double prime of x plus t, right? Right. Since x into f1 double prime of x plus t plus f2 double prime of x plus t equal to dou square z by dou t square, right? And this becomes dou square z by dou x square equal to 2f1 prime of x plus t plus, just replace this using dou square z by dou t square, right? Now bring this term to LHS. This becomes dou square z by dou x square minus dou square z by dou t square equal to 2 into f1 prime of x plus t, right? Fine. Now bring this 2 to LHS. You'll get 1 by 2 of dou square z by dou x square minus dou square z by dou t square equal to f1 prime of x plus t. So we got the value of f1 prime. Okay, and also we have the value for x into f double prime plus f2 double prime, which is dou square z by dou t square. Now using 6 we'll find the required partial differential equation. Let's see that. We have using 6 becomes, otherwise dou square z by dou x dou t equal to f1 prime of x plus t plus x into f1 double prime of x plus t plus f2 double prime of x plus t, right? That's what we are having in our equation 6, right? Now what we'll do is we'll just replace this term using this value, and we'll replace this using dou square z by dou t square. Okay, then this becomes dou square z by dou x dou t equal to f1 prime of x plus t can be replaced by 1 by 2 into dou square z by dou x square minus dou square z by dou t square. I'm just getting y all the time. Okay, it's t not y. Fine, plus replaces by dou square z by dou t square. Okay, fine. Now what we have to do is, here we are having 1 by 2. Take LCM and bring this the 2 to LHS, or easy way, just multiply both sides of the equation with 2. Okay, multiplying both sides of the equation with 2 gives 2 into dou square z by dou x dou t equal to 2 into the term plus 2 into dou square z by dou t square, right? Here 2 gets cancelled and you will get 2 into dou square z by dou x dou t equal to dou square z by dou x square minus dou square z by dou t square plus 2 into dou square z by dou t square. This gives us 2 into dou square z by dou x dou t equal to dou square z by dou x square minus dou square z by dou t square plus 2 into dou square z by dou t square gives plus dou square z by dou t square, right? 2 minus 1 gives 1. So we'll get plus dou square z by dou z square. Sorry, dou square z by dou t square. Okay, fine. Now we can write the same equation as dou square z by dou x square plus dou square z by dou t square equal to minus 2 into dou square z by dou x dou t. Okay, now it's plus. Okay, now bring this term to LHS and you'll get dou square z by dou x square minus 2 into dou square z by dou x dou t plus dou square z by dou t square equal to 0, which is the required partial differential equation. So you got partial differential equation. Fine. So if we don't want to shift this to LHS and this to RHS, we can write the same term as, just bring these two terms to LHS, then you'll get 2 into dou square z by dou x dou t minus dou square z by dou x square minus dou square z by dou t square equal to 0. Now multiply both sides of the equation with minus, then we'll get dou square z by dou x square minus 2 into dou square z by dou x dou t plus dou square z by dou t square equal to 0. You'll get the same thing. Okay, it's better to write like this and write a partial differential equation, required partial differential equation. Okay, this looks good. You can write in any of these forms, that's not a problem. Okay, fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.